Today is it's a challenging day for me to teach. How's that? So there's other content where it's easier for me to help you kind of understand it. This piece a little bit more challenging. So I'm going to make some adjustments from third hour. We're going to switch a couple of the problems, but this one went pretty well third hour, so we're going to leave this one right here. What makes this third problem different from the ones we've looked at before? Yeah, notice that the numerator is of higher degree than the denominator, isn't it? So let's go about working with that, okay? And I will start with the y-intercept. I'll start with the x-intercept as well. How do I determine the y-intercept again? Plug in 0 for x. If x is 0, what's the output? 3/2 is going to be the y-intercept. How do I determine the x-intercept? Look where the top is equal to 0, so x, so we're going to factor to x minus 3 and x minus 1. So that means I have positive 3 and positive 1. So I already know that the graph crosses at 3 and 1, and it also crosses at 3/2 for the y-intercept. Sir?
Do you mind explaining how you got 3/2 for the y-intercept?
So we find the y-intercept by plugging in 0 for x.
Oh, okay.
So we plug in 0 for x. Everything that has an x goes away. Very good. Yep. Okay. Now, before I go to the horizontal and vertical asymptotes, what I'd like to do is I'd like to just see what happens when I divide this. So I'm going to divide x plus 2 into x squared minus 4x plus 3. So what do you multiply x by to get x squared? X. Multiply that back through, we get x squared plus 2x. We subtract, we get negative 6x plus 3. What do you multiply x by to get negative 6x? So I have a minus 6. So I have negative 6x minus 12. Positive 15. So it's plus 15 over that x plus 2. Or if I were to write it in a form that you are used to seeing, I'll write it like this. 15 over x plus 2 plus the x minus 6. Now, this gives me a lot of information about what the graph looks like. First of all, can you see what number can you not plug in for x? So that's where something crazy happens, okay? And in this situation, you have that vertical asymptote. So at x equals negative 2, a vertical asymptote. Or in other words, you can see a shift to the left 2 units. Are we all okay with that? What's different about the end of this? There's an x in it. Now, if it was just a minus 6, you would then shift it down 6 units. Agreed? Anybody want to guess what I do if it's x minus 6? I like your idea. So if it was just negative 6, we would draw a horizontal line through negative 6. If it's x minus 6, we're going to draw a line with a slope of 1. Do you know how to graph y equals x minus 6? Yes. So since that's what's sitting off on the end, That's what we graph. So instead of a horizontal asymptote, we call this more of a slant asymptote. Is everybody okay with that? All right, now I have to figure out where to draw these curves. I'm going to go to this side. Do you think I draw it in the top or the bottom? Why? I've already got dots there, right? So I'll use those dots to figure out where to draw it. Do you think I draw it in the top or the bottom? Hard to know, isn't it? You see a squared, so you think top, but you're used to trying drawing them in opposite quadrants, right? Do you have an x-intercept on this side? No, we don't. So it doesn't cross the x-axis over here, does it? See, if you were to draw it here, it would cross the x-axis. And we don't want to do that, do we? So you know it's here where it does not cross the x-axis because you don't have x-intercepts. Suppose that we came up with an x-intercept of -5. Well, then you would know you would draw it in this side. But there is no x-intercept, so draw it on the other portion. Okay? This one? So if it was here, then it would no longer be a function. Can't have one graph stacked on top of another because it wouldn't pass the vertical line test. Better? Got to be in one or the other. Okay. Let's move along.
How do you write that on a test? Like horizontal.
I would be looking at your graph is what I would be doing. Okay. Sometimes it's just best to divide right away. In this situation, I'm just going to divide. You guys all know how to find the x and y intercepts now, right? So let's skip that portion and let's just focus on dividing. X plus 2 goes into 3x plus 6. What do you multiply x by to get 3x? Subtracting, you get. So what makes this different than all the other problems we've done before? There is no remainder. When there's no remainder, you don't have this vertical asymptote anymore. You actually have a hole in the graph. It may sound weird because you've never really seen it before, but I'll show you something kind of neat as we diagnose it. Here's what the graph looks like. When we divided, what did you come up with? 3. And would you agree you could have taken this thing from the very beginning and said 3 times x plus 2 over x plus 2 and just seen that they would cancel? Yeah. So it turns out that this wants to just look like y equals 3. What does that look like? Looks like that. But there's one small issue that happens here. And there's a hole. And you can tell where the hole is going to be. There's always a disruption that happens whenever the denominator is equal to 0. So look at this one here. When was the denominator equal to 0? -2. And notice how we had a disruption there. You had this vertical asymptote. Well, if you look at this situation, again, when is the denominator equal to 0? -2. Because it divided evenly, you're going to have an issue at -2, but instead of a vertical asymptote, it's just going to be a hole. So I go to where -2 is. I'm just going to put a hole right there. Negative infinity to negative 2, union negative 2 to infinity with, yep, parentheses. Now, if you have to give the coordinate of where the hole is, first of all, you knew it was going to be at an x value of negative 2. What's the y value of the coordinate for the hole? It's 3.
Yeah, because negative 2 is like undefined
Denominator, wherever the denominator is equal to 0, yes. Yep, yep. Okay, so I'm going to take this 3x plus 6 here, and I'm going to go to my calculator, and I'm going to divide it by that x plus 2, and I want you to see what happens, because part of you is still wondering, is that really a thing in math, right? You're like, it just seems weird, like he's just making stuff up now. Well, oh. Did you see my calculator? See how it drew the graph at 3? And what happened when it got to negative 2? Yeah, and so, you know, you can get a little curious. You're like, well, I'm going to trace this. Oh, I got to take my expression off so I can't see. Let's see, where is it? Expression. Okay, so we're gonna trace this, and notice as the x value gets close to negative 2, look at the y value here. It stays at 3, and as I get closer and closer and closer, I'm almost there, and then poof, just like vanishes. And if you move a little further, oh, comes back right there. And if you went into the table, if you typed in, like, say, you know, negative 2.2, negative 2.1, negative 2, negative 1.9, you know, you can see, again, it will give 3 until you get to that negative 2 spot. So when it divides evenly, there's a hole. All right, last example. Last example is x squared, whoop, sorry about that, plus 5x plus 4. I'm sorry, plus 4x plus 3. X squared plus 4x plus 3. Sorry about that. So just trying to change the problems because I really didn't like how it went second hour with a couple of these problems. Or third hour, excuse me. So again, sometimes it's just best to divide right away. Will these divide evenly? Does the top factor to x? Good. X plus 3 and x plus 1. So, cancels the x plus 1s. So what shape does the graph want to be? What does it want to look like? X plus 3. Do we know what that looks like? Yeah. Except it doesn't look like x plus 3, does it? There's a hole. Can somebody tell me the x value for the hole? Negative 1, wherever it's undefined, right? That's where the disruption happens. Anybody know the y value? If I go to negative 1, the y value would be positive 2 right there.
Oh, you gotta go for x and y.
And if you can't tell by your graph, you could just plug it in right here. Watch, negative 1 plus 3 is 2. And so I'm going to go back to this spot right here. And I'm going to take that out, just like so, and that's where it is. Because I think that this is like the coolest thing in the world. We're going to do this one last time. X squared plus 4x plus 3 divided by x plus 1. Oh, and there it is. Yep. Kind of crazy. I will answer that in just a second. You guys are set to go to your assignment. The next 2 days we have time to work on our homework and study guide. Test on what day? Thursday. See you Thursday. 1 and 2.